Alright, hello, welcome. In this video I'm going to be proving the product rule for you. This is the first of two different proofs I'm going to give you, but this one is for kind of like right when you're beginning calculus, right? I'm going to use the definition of the derivative, I'm going to use some algebra tricks, and I'm going to show you using the definition of the derivative that, the familiar product rule works. And then in the later video I'm going to show you about how to show this much easier after you have a tool where we can take the derivative of an implicit equation, which you may not have yet depending on how far are you along in calculus. So I'm going to start off with the limit definition of the derivative. So remember that the derivative is, so this derivative that I'm interested in finding that's the limit as h approaches 0. Really, it's the limit as run goes to 0 of rise over run. Okay, so, well, the rise would be, what happens when I bump up x by h. Okay, so f of x plus h, g of x plus h, minus f of x, g of x, all divided by h. Now what I'm going to do is I'm going to add a clever form of 0. Okay, really what I'm going to do is right in here, right between these two things, I'm going to subtract something and then I'm going to add it back. So in total I've added 0 to the fraction, so I haven't changed its value, right? The thing, I'm going to start off by subtracting f of x plus h multiplied by g of x, and then I'm going to add it back. And it's going to be like, well, why would you do that? But I think that, once I get it on there, you'll see. So I'm just going to, add in the clever form of 0 real quick. All right, there you go. I've subtracted f of x plus h times g of x, and then I added it right back. Okay, so I haven't changed the value of this fraction. And now what I'm going to do is I'm going to split this over, over this addition right here. Okay, so really, split on that. And so I'll have now the sum of two limits. Okay? And they will be added together like that. So I'm going to have first, okay, f of x plus h, g of x plus h, minus f of x plus h, g of x divided by h. And maybe I think I will copy that first, and then I'll factor. So and then over here, I'll have the f of x plus h g of x minus f of x g of x. H goes to 0. Okay. F of x plus h g of x minus f of x g of x, all divided by h. So really what I've done here is I've undone addition with a common denominator, right? I could add these together, the same denominator, and I just kind of combined the numerators. But I want to undo that right now, and maybe you can start to see what's going on here. I'm going to factor an f of x plus h out of this. And I want to factor it all the way out of the fraction. I'm going to write it in front of the fraction. So I'll have f of x plus h. And then this fraction will be, let's see, I'll be left with a g of x plus h minus g of x divided by h. Okay, and then I'm going to do the same thing over here. So plus limit as h approaches 0. Okay, now I'm going to factor out a g of x from both of these terms. And I'm going to be left with an f of x plus h minus f of x divided by h. Now, let's think about what happens as h goes to 0 here. As h goes to 0, this goes towards f of x, right? F of x plus 0. All right, well, we can do that. So that's f of x. And this, well, really what I'm doing, and I'm not going to write it as a separate line, but I'm considering the limit of the product is the product of the limits, provided that the limit of each factor exists. So the limit of this thing in square brackets as h goes to 0, well, that's the definition of the derivative of g. So it's going to be f of x times g prime of x. And then over here, as h goes to 0, I got g of x here. G of x doesn't care what happens with h, right? It only depends on x. So I'll have a g of x there. And then this limit, okay, the limit of this thing in square brackets, that's the definition of the derivative of f. And this is what I had hoped to show in the first place, right? Wait, no, derivative of f. Okay. So yeah, f g prime plus g times f prime. Okay? And this is why the product rule works.